Hello everyone, today I'll be explaining the relationships between the roots and the coefficients of a quadratic. However, I will mention that this is only for year 11 advanced math, but it will expand into year 11 extension 1 math, and we want to see the relationships between the roots and coefficients of a cubic. This is only for a quadratic. Now let's get started. The discriminant tells us that for quadratic, there can be 0, 1, or 2 real roots. But if we consider complex numbers, which we will learn about later, and equal roots, a quadratic always has 2 roots. We can call them alpha and beta. Now, a general form for a quadratic is this: ax squared plus bx plus c. What we want to do here, ultimately, is see the relationships between alpha and beta and a, b, and c. This is what we're going to do. We can do this in 2 methods. I'm going to show you both. This is method 1. Now, at this point, we've all learned that another way we can represent a quadratic is this: x minus alpha times x minus beta, okay, equal to 0. The reason why is because when you expand this, you'll get this, basically. And the reason why alpha and beta are the roots is because when you divide 0 by either of these, for example, when you divide 0 by x minus beta, you'll get x minus alpha equals to 0 and x equals to a. And vice versa, you can do this with the factor of x minus beta, and you'll get beta as a root. Now, so here we know that this is also equal to ax squared plus bx plus c. Okay, what we want to do is now compare these roots with these coefficients. Okay, we can get started. However, there is an issue that you guys must know right now. In most cases, when we expand this, in most cases we don't actually get this. And the reason why is that when you expand this, every time the coefficient of x squared, so a, will always turn out as 1. Okay, you can't do anything else. So for this form, the coefficient of x squared will always be 1. The way we can fix this is that we can just add a here. And when we do that, when we expand this left-hand side, we'll always get the correct form. So let's start simplifying. A, we can expand the left-hand side. A times x minus alpha times x minus beta is basically x squared minus x times alpha minus x times beta plus alpha beta, which is equal to ax squared plus bx plus c. Okay, now what we can do here is we can do 2 things. We can either expand this times everything by a, or we can divide both sides by a. To see the result clearer, I'm just going to divide both sides by a, okay? Here we get x squared minus x times alpha minus x times beta plus alpha beta equals to x squared plus b over a x plus c over a. Notice how we're getting to the coefficients and the roots easier now. Okay, now we can then simplify this into this: x squared minus alpha plus beta times x equals to alpha beta, and this equals to x squared plus. Let's move this so you can see clearer. This is one of the most important steps. X plus c over a. Now, if you guys look closely, we can see that we've turned the left-hand side into the general form of a quadratic, and you can see how the coefficients that match up with the roots. See how negative alpha plus beta matches up with b over a, and alpha times beta matches up with c over a. This is effectively how we can say that negative alpha plus beta is equal to b over a, which makes it alpha plus beta equals to negative b over a. We can do the same thing here with the c term, sorry, the constant, yeah. We can say alpha times beta is equal to c over a. This is very cool. We've just shown the relationship between the coefficients of a quadratic and their roots. Now, if you didn't understand, that's okay, because we can do this another way. Let's do this another way so you guys can see more clearly. So at this point, we've learned that we can find the roots of a quadratic with the quadratic formula. We can say alpha equals to negative b plus, not minus, because we can have minus for the beta, beta root. So we have plus b squared minus 4ac, and we have beta equals to negative b minus square root b squared minus 4ac. Now both of these are divided by 2a. Okay. Just like so. So now basically when you want to see the relationships between alpha and beta with a, b, and c, we can say, for example, alpha plus beta is basically equal to the right hand sides added together, because this is alpha, this is beta. Alpha plus beta is basically these two right hand sides together, added together. We can say the same thing with alpha times beta, where because this is alpha and this is beta, this times this gives us this times this. So alpha times beta is equal to the two right hand sides multiplied together. Now if you do this in your own time, you'll get alpha plus beta is equal to negative b over a when you do some basic algebraic work, and alpha times beta is equal to c over a. You can do this with this second method as well.